So I want to show you in this exercise set, right, you have some concepts that we took a look at last week. Given a graph, right, determine any absolute local min and max values. Last week we did also talk about taking a look at graphing. And here are some case scenarios, but what I wanted to show you here is that all of these functions from 15 to 28 are we sketch these graphs by hand by using transformations that we learned in pre-calc. Here, they're asking you to find the absolute and local max and min values given these graphs. Then the next grouping here was just finding the critical numbers of these particular functions. And then here, to find the absolute max and min, which we were focusing on because it does ask you to find the critical values as well. I did want to take a look at one more example before we head out. And I want to take a look at number 42. And this one is just asking for us to find the critical values. So when you get to number 42 here, this is asking, given your function is g of x, this is going to equal the square root here, which is going to be 1 minus x squared, which is the same as 1 minus x squared to the 1/2 power. So in order for us to find g prime of x, you're going to need to use the chain rule. You're going to get 1/2. This is going to be 1 minus x squared to the negative 1/2 times the derivative of the inside, which is going to be a negative 2x. So you're going to simplify and you're going to get g prime. The 2's are going to cancel and you're going to get a negative x, which is going to be all over and this would be the square root here of 1 minus x squared. And I wanted to take a look at this particular example because to find those critical values, now when you set that first derivative equal to 0, so when will a minus x all over the square root of 1 minus x squared equal 0, or when will a minus x all over the square root of 1 minus x squared equal an undefined case? The other ones didn't have it, so that's why I'm taking a look. This case, to be 0, is only when the numerator is going to be 0. So a minus x is going to equal 0. X is going to equal 0. So that's one value. Undefined case is when this denominator, so when will the square root of 1 minus x squared equal 0? You could solve this by squaring both sides. You'll get 1 minus x squared equals 0. Bring the 1 over, divide by negative 1. X squared equals 1, and therefore you get x to be plus minus 1. Or you could have just seen that plus minus 1 would have yielded 0 on the denominator, and you cannot have that. So in this particular case, our critical values are x to equal negative 1, x to equal 0, and x to equal a positive 1. So I recommend that when you are practicing, you take a look to see what type of functions you're practicing. See, that's the thing of you don't know what function you're going to be given when you're asked. So, and the algebra is a little bit different. And, you know, one that is problematic is always the absolute value family. So I would take a look at especially number 34 and see what you come up with. And then when you get over here, right, the functions are just getting a little bit more involved, but the concept is still the same. And so what we're going to do is we're going to take a look at how we're going to use these critical values, not in the next section of, well, yeah, in 3.2, but primarily in 3.3 and 3.4 when we get into the graphing of this, and 3.5, I think, where we're in the optimization type of problems.